Again, good morning. I believe I'm the only non-dentist attending this meeting. I'm a statistician by training, and over the years I've taught the statistics, biostatistics to dental students and medical students and public health and pharmacy and nursing, all those areas in health sciences. I'd like to talk about assessment of errors and misused statistics in dental research. Now, first I'd like to talk about prevalence of misuses, and then I'll briefly explain ordinal data, and then I'd like to discuss 8 misuses of statistics. Now, I know 20 minutes will not do justice in properly explaining all these 8 misuses, but I'll do my very best. And then if I have a time at the end, I'll talk about why rampant misuses of the statistics. Now, over the years, I've done a lot of reviewing and refereeing of the manuscripts submitted to dental journals and medical journals, for example, for the publications. Of course, my part is only to check the statistical applications in those research papers. And I have been absolutely amazed and saddened and disheartened by the fact that there are so many small errors and sometimes very serious errors in statistics. And I got to think, why such a brilliant scholars and investigators in dentistry and medicine make such a horrendous mistakes? And it's just not me, but statisticians have long been aware of the prevalence rate of statistical errors and misuses in the research papers. Now, approximately, I'm sorry, I don't have a pointer, a laser pointer. Approximately 72% of the first person who had done the formal investigation into this was Shaw and Cotton. In 1966, they sampled 295 papers from 10 medical journals. And they found that 72% of the papers contain statistical mistakes from minor to major. And in 1977, Gore and his colleagues took 62 papers from British Medical Journal. Remember, BMJ is one of the top journals in medicine in the world, and they found approximately 51.6% of the papers contain some statistical errors. 1984, Felton and his colleagues took a sample of 47 papers from arthritis and rheumatism published between 67 and 68, and they found that 60% contains some sort of statistical mistakes, and they again had done the similar studies, sampling 74 papers from arthritis and rheumatism published in 1982. They also found 66% of those papers contain statistical mistakes. And in 1990, Gardner and Bond took 45 papers from British Medical Journal, and they found out that 16% of those papers contain rather serious statistical mistakes. Now, in their paper, they did not state what that serious statistical errors constitute. But anyway, 16% contain very serious errors. Now, in 1995, McGuigan took 164 papers randomly sampled from British Journal of Psychiatry and found that 40% contained very serious statistical errors. So again, they didn't say what the serious statistical errors are. Again, in 1996, Welch and Gabby took 145 papers from the American Journal of Obstetrics and Gynecology and found that 19% contained very serious statistical errors. And once again, they didn't say what the serious statistical errors are. And then 2002, Kuo took 178 papers from BMJ, British Medical Journal, and Journal of American Medical Association, and Lancet, and New England Journal of Medicine. And of course, these are 4 top journals in medicine in the world. And amazingly, and Kuo was quite amazed that 60% of those papers contain some sort of statistical mistakes. Now, at this point, after having read Kuo's paper, I've done investigation myself, and I found out that none of the similar studies has been done in dental science. So what I did was I took altogether initially 418 papers published in 10 dental journals from American Journal of Orthodontics and Dental-Facial Orthopedics all the way through Pediatric Dentistry, published between 1995 and 2009. And I had to delete 111 of those papers because those papers did not present any sort of evidence for me to judge whether or not there was any sort of statistical mistakes. So based on 307 papers, I found out that 51.5% of the journals published in those 10 dental journals contain minor to very serious statistical mistakes. Now, how do I select these 10 dental journals? I asked the dental faculty members, and these are the journals they suggested. Now, what this means is that most likely the conclusions they have drawn in those research papers could possibly be very wrong, and that can be very detrimental to patient care. Well, this sort of statistical mistakes is not unique to dental and medical journals. Alan Blinder, who used to be the economics advisor to President Clinton, he once said that there are probably untold number of statistical errors buried in economics literature. So this is very common. Now, I don't mean to criticize social science, but if you go to social science, there are even more statistical mistakes. And there's a reason for that. I'm going to talk about that just a little bit in just a couple of minutes. Now, let me just quickly go over ordinal measurement scale. I know you as dental professionals collect lots of ordinal measurement scale data. The categories can be ordered or ranked. The amount of difference between any 2 categories is not quantified. The amount of difference between any 2 categories cannot be quantified naturally in any numeric values. For example, disease state of cancer, cancer stage 1, cancer stage 2, or 3, or 4, and these are not quantifiable, and you certainly cannot quantify the difference between stage 1 and stage 2 cancer. And of course, dental pain, dental fear, dental anxiety, tooth mobility, and dental sensitivity. These are all ordinal measurement type of data which you deal with often in your profession. Now, by nature, the ordinal data is extremely subjective, and in a lot of scientific research, not only dentistry, medicine, but the nursing science, not to mention the social science, they collected tons of ordinal data. And most often when people deal with ordinal data, they make a lot of mistakes and statistical mistakes. So let me just give you a precise example. How much pain have you experienced? Typically you provide these 5 categories: no pain, mild pain, slight pain, severe pain, and extremely severe pain. Of course, these are 5 categories representing the ordinal data, and of course these categories cannot be properly quantified in any sort of numeric value naturally. We can artificially assign these numbers 1, 2, 3, 4, 5, and that's where the often problem lies. And let me elaborate that in just a minute. Now let's take another example here. I'm satisfied with dental care service provided by dentist, and usually the respondents are provided with 5 choices strongly disagree, disagree, neutral, agree, and strongly agree. And these 5 categories, of course, not quantifiable, and you certainly cannot measure the difference between any 2 categories. But you can artificially assign numbers like 1, 2, 3, 4, 5. And these are artificial numbers assigned to these categories for the purpose of data analysis. And this was first suggested by psychologist Likert, and that's why this has been typically known as a 5-point Likert scale. Now, because this 1, 2, 3, 4, 5 are assigned to these categories, too many people think that these values measure these categories, and that's where the problem starts. Now, a little bit of improvement of quantifying this ordinal data is what is known as a visual analog scale. You provide respondents with a straight line, and the left-hand point is no pain, and right-hand point is extremely severe pain, and you let respondents mark wherever they think the amount of pain they feel. And you simply measure the distance. So the first patient responded, oh, my pain is 22.5 millimeters, and another patient 87.7 millimeters. So you now have a continuous measurement which is slightly better. However, you remember that the VAS scale is still very, very subjective. I mean, I can apply equal amount of pain to all of you here, but basically the feeling of pain is inherently subjective. You're going to get very subjective, sometimes misleading data. So you have to be very, very careful. Now let me talk about misuse 1. Too many, if not all of the research papers in medicine and dentistry and nursing and all the other areas, they state this based on 575 subjects who are randomly chosen. Now, when you talk about the survey questionnaire, you rarely ever get random sample. Now, you may get a random sample of 1,000 patients to whom you provide this questionnaire, but they have to decide after filling out the survey questionnaire whether or not to return the questionnaire. In other words, basically, the patients decide. So this is what is known as a self-selected sample. So there's a huge difference between self-selected sample and random sample. The self-selected sample is extremely biased, and often it is dangerously biased. Let me just give you a very quick, very dramatic example. In 1936, there was a presidential election in the U.S., and we had 2 competing candidates, Republican candidate Alfred Landon and the Democratic candidate, incumbent President Roosevelt, based on 2.3 million respondents out of 10 million sample ballots mailed out to the respondents. Based on this 2.3 million sample size, and this Digest, the magazine, predicted that the Landon will win the election. Well, surprise, it turned out that Roosevelt pulled off one of the greatest landslides of history, winning 62% of the popular votes. Okay, now what was the problem? I mean, you had a huge 2.3 million samples. How can 2.3 million sample go wrong? Well, it's because it was a self-selected sample. I mean, that's how dangerous self-selected sample is. So too many researchers, investigators state, well, based on random sample of 575. Now, you as a doctor say that your patient has a liver cancer when your patient has a brain tumor. I mean, that can lead to all kinds of very, very serious problems. So make sure that if it is a self-selected sample, it is stated as a self-selected sample. Now, as I said, 1, 2, 3, 4, 5 are labels. These are not the quantifications of this classifications. Now, you don't have to assign 1, 2, 3, 4, 5 to these 5 categories. You can assign any 5 different numbers. For example, 0, 2.2 to mild pain, 5.6 to slight pain, 16 to severe pain, 20.7 to extremely severe pain. Or you can even assign negative numbers, negative 15, negative 6.5, negative 2.3, 5, 8.4. Any 5 different numbers. Because these are labels, they don't represent anything. Okay? So the values 1, 2, 3, 4, 5 are completely arbitrary and have no sensible quantitative meaning at all. And these are nothing more than convenient labels. Now, if you look at the research papers, you can go out and grab any research paper published in prestigious journals, and you will see this. Very typical summary descriptive statistics. You have a female samples of 173, male samples of 202 patients, and the average is 2.13 plus minus 1.14, and so on and so forth. And your data is ordinal data. So they've done the statistical analysis based on those 1, 2, 3, 4, 5. And I have to communicate to you as clearly as I could. And this is extremely misleading. In a sense, this is absolutely a nonsense. So, and unfortunately, too many investigators present that. Well, let me just explain. Suppose there was the labeling system A, 1, 2, 3, 4, 5. Suppose you have a different labeling system, B, and you have another labeling system, C, and you could get very different average or standard deviation based on the formula. And then based on the labeling system A, the female average is 2.13. 2.13 is very close to being 2, which is mild. So you may conclude that based on my sample of 128, the female patients felt mild pain. However, if you have a different labeling system, you could get minus 13.6 as an average. Minus 13.6 is being very close to no pain. Your conclusion could be, on the average, my patients felt hardly any pain. This is identical data, but this is how nonsense you can get. So you have to be very careful when you have ordinal data. Okay. Now, average is as simple a concept as you can get in statistics. I can't think of any simpler concept in statistics. Then why do people misuse even such a simplest concept as average? I blame people who taught the statistics, because they didn't teach you the concept of average. They taught you how to calculate the average. Now, I grab students in my classroom and ask them to explain what average means. They know how to calculate, but hardly anyone understands the concept of the average. So let me just briefly describe the concept of average. Suppose you have a mercury concentration in amalgam. You have 5 samples, and this is artificial data that I made up. Now 6.5, 5, 3.5, and 7, 9.5. So you took an average, you add those 5 numbers, divide by 5, you're going to get 6.3. 6.3 is the average mercury concentration in those amalgam samples. Now, what does this 6.3 mean? Well, unless you know the concept of average, you're not going to be able to explain very clearly. Yeah, I bet 99% of the students won't be able to explain. Now, suppose you have this stick that has a uniform mass density throughout. Left-hand point is marked with the smallest value of 3.5. Right-hand point of the stick is marked with the largest data point, which is 9.5. And you have 3 intermediary values are appropriately scaled. Let's assume that each marker is tied with the equal weight, 1/5 of a kilogram, and the point at which you can perfectly balance this stick on the edge of your knife is where the average is. So in this case, 6.3 is the point where you can perfectly balance this stick. Okay, now you have that understanding. So let's go back to the ordinal data, and you will be able to see why the average doesn't even exist when you have ordinal data. Now you have a same uniform mass density stick here with a uniform mass density. Left-hand point is no pain, because no pain is the smallest pain level. And the right-hand point, of course, is marked with extremely severe pain. Now you have three categories: mild pain, slight pain, and severe pain. We know that mild pain is more pain than no pain, but less pain than slight pain. But we don't know exactly where we should be marking the mild pain, because it cannot be quantified. We don't know how much more pain mild pain is than no pain. What about the slight pain? We know the slight pain is more pain than mild pain, but less pain than severe pain. But we don't know exactly where we should bring the marker, because that is not quantifiable. And likewise for the severe pain. In other words, we cannot find the balancing point, because balancing point in this case does not exist. So too many researchers are presenting, when they had ordinal data, the average and standard deviation, which do not even exist. And this is a very, very misleading and very serious mistake. Now let's go to a standard deviation. If you look at the formulation of a standard deviation, well, you have to know what the sample mean x bar is, the mean is. Now average doesn't exist, which means you cannot estimate the standard deviation. So when you have ordinal data, you cannot have not only the mean, but you cannot even have a standard deviation. Okay, let me quickly move on to misused number 3, Pearson correlation coefficient, which is a wonderful statistical procedure to measure the relationship between two variables. Let's say you have one variable, which is a question number 3, how much pain did you feel during the treatment, and you have ordinal data. And then you have another question, question number 7, my dentist is caring and kind and warm, and you have again the 5 categories, which represents the ordinal data. And you have this three labeling system, and based on this identical data, and you calculate or you estimate the Pearson's correlation coefficient. Now if you calculate the Pearson's correlation under label 8, you get correlation approximately 41%. On the label B, you have a 29%. On the label C, you have a 36%. What's wrong with this? I mean, you have identical data depending upon the labeling system. Labeling system is arbitrary. You can have any 5 different numbers assigned to those 5 categories. And this definitely means that the Pearson correlation coefficient is absolutely nonsense when you have ordinal data. Now, I used to go to a dental research conference, and too many investigators, when they make a presentation, they calculate the Pearson correlation coefficient, which is not very meaningful. So in this case, what you should be using is a Spearman rank correlation. And depending upon, no matter what the labeling system is, because you have identical data, Spearman correlation is the same, and that's the way it should be. Now, if you look at the formulation of Pearson correlation coefficient, is very obvious, because you then have a sample mean for the first variable, you then have the average for the second variable. You don't have those averages existing. So how could you possibly come up with a Pearson correlation? So that's how nonsense things can become. Okay. Oops. Unfortunately, my time ran out at this point. So would you want me to just discuss the regression model and then quit after this? Or? All right. Okay. Thank you. There are a number of papers I can remember. I can quote you right off the bat 10 such research papers published in rather prestigious dental journals. They try to predict vast visual analog scale from the ordinal responses, those 5 categories. And they come up with a very nice regression function like this. When you look at the regression graph like this in the journal paper, it looks very impressive, and they even present the regression function, and then R square. Well, remember, this is ordinal data, 1, 2, 3, 4, 5. And I have to tell you, this is absolutely nonsense and very, very misleading. There are two major problems with this particular paper. The investigator, whoever did the statistics, didn't understand clearly what the ordinal data means, and furthermore, that person did not understand the fundamental concept of regression model. That's why he's making these horrendous mistakes. Now you look at where 1, 2, 3, 4, 5 numbers are. They are marked equidistant, 1, 2, 3, 4, 5, as if they are meaningful quantitative variables which represent those 5 categories. But remember, these are not numeric values representing those 5 categories, and these are simply the labeling. For example, now in the US we have social security numbers. I know Dr. Goran has a social security number, and you have a social security number and so forth. Social security numbers do not measure anything. It doesn't measure your height, it doesn't measure your weight, it doesn't measure your income. It's just a convenient label that government assigned to you. Suppose you take these 5 citizens, American citizens, you take the average of those 5 social security numbers. What does that represent? Nothing. Nothing. It is totally meaningless. So thank you very much. I ran out of time, unfortunately. If you have any questions, I'll be happy to address. Yes. Yes. Oh, okay. Yeah. Again, if you I have to say this. I ran out of my time, but if you allow me, I will go back. And I said that if I have a time at the end, I will address that problem. And this is a chronic problem. Just about every statistician runs into when they teach statistics in medical school and dental school and the other health sciences field. First of all, in order to practice statistics, you do not need a license. This is not a licensed profession. Now, you as a dentist, before you can treat patients, you have to have a certified dental license. So, you can take 1 or 2 statistics classes and you can go out and claim, I can do statistics. Yes, you are allowed to practice statistics. Suppose I took a couple of courses in brain surgery. Would you let me operate on your brain? No. Okay, that's another thing. Now, the other thing is this is a more serious problem. The statisticians, so-called statisticians, who teach statistics. There are 2 types of statistics teaching. One is mechanical teaching. I would call it robotic teaching. The other is conceptual teaching. Now, conceptual teaching is very rigorous. It's very difficult for the instructors to prepare, and it's very hard on students because they must think rigorously. Now, mechanical teaching is just like when I teach the average. Okay, here are 5 numbers. You add 5, divide by 5. This is the average, and that's not doing anybody any favor. That's not a good that's not a good instruction at all. And I don't do it that way. But then, when I try to teach conceptual statistics to the students, it not only takes more time, but it's so rigorous on the students feel the pressure, and they naturally complain. Complain. Now, where does the complaint go to? Usually the head of the department or dean. Now, statistics instructors, they are human beings after all, and when there's a complaint, and then you get a call from department head or dean, and they will say something. And then over the years, they gradually give up, and they start teaching this mechanical teaching. Students are very happy, not realizing that they are not learning anything. But until I retired, I never succumbed to that kind of a pressure because ultimately I know they would appreciate me. I always try to do my very best to teach them concepts rather than mechanical teaching. Mechanical teaching, well, these days you have a computer statistical software package that can do the job for you, but you don't understand what it means. And that's why there's a lot of mistakes in dental literature and medical literature, because investigators did not learn the concepts. I know I've worked with dental faculty members, medical faculty members, and so on for a number of years. They're brilliant scientists, but they make very foolish, easy mistakes because they did not learn the statistics properly. Who to blame? The instructors. And the other thing is that dental schools or medical schools, they wanted to be cheap. So they don't go out and hire bona fide statisticians who have proper academic credentials. And they just grab somebody. I used to teach, I used to take 3 or 4 statistics courses when I was in graduate school. Okay, fine, come teach us statistics. So as I said, the second from the bottom, misteaching or substandard statistics instructions. And you have to know what you're getting, seriously. And I try to communicate to my dean of dental school and medical school and so on and so forth. And after many years, I was able to convince them, but many statisticians fail because most often they put the finance ahead of, unfortunately, anything else. And then the student complains. And you, as an administrator, the last thing you want is complaints from the students, whether their complaint is legitimate or not. And most often, it's not. And over the years teaching, I would say 80-20 rule. 80% of the complaints come from the bottom 20% of the class. In my career, I never had a student complain about my teaching. It's always the people at the bottom. Just sharing my experience since you brought up the question. One time I had a call from Dean, and Dean said that 3 students in the class complained about my teaching. This was right after midterm exam. So I said to Dean, well, before you speak, I can bet you anything in this world, because I had a scorebook, this was right after the midterm exam, and I had 5 students who are failing in the statistics class. I bet you, Charlie, I bet you, these 3 students are the ones who complain. You don't have to tell me who they are, but I know. And he was just sitting there smiling. Thank you very much for listening. And thank you.